Hey everyone! So today we're going to talk about platelets, plasma, proteins, and some disorders. Your job is to take notes, focus on the things that are bolded and that I emphasize as I'm going through these, and make sure that you do your summary at the end. Feel free to pause this video, that way you can get everything written down instead of me just flying through everything. So, for platelets, we've talked about how erythrocytes are red blood cells, leukocytes are white blood cells. Now I'm going to tell you that platelets are also called thrombocytes. So a good way to remember this, if you have a blood clot and you need to stop the bleeding, that area is probably throbbing a little bit. When we did our blood typing the other day, after you pricked your finger, you may have noticed that you felt a little bit of a pulse or it felt a little warm. It was throbbing. So the platelets that help clot that bleed are called thrombocytes. Now, they are originally produced from megakaryocytes. I'm not going to ask you guys on that test, but these are really, really large cells in the bone marrow that eventually are going to be differentiated thanks to thrombopoietin in order to produce the thrombocytes. So very similar to how erythropoietin produces red blood cells, thrombocytes are produced by thrombopoietin. Now, platelets, similar to red blood cells, do not have a nucleus, and that's going to leave more room for them to have functional proteins in order to get their job done. They only live about 10 days, and their job, and this is the most important thing and the thing that you need to write down, is to form blood clots. They help close breaks in damaged blood vessels, whether that is a vein, an artery, or even a capillary or arterial venule, but we're fixing that open wound and closing it up so that way we do not lose as much blood. We tend to have a lot of those, and they work by combining together in order to form a meshwork to catch all of the red blood cells. So the platelets themselves are not going to plug it up if there is a massive bleed, but instead they will knit together this fibrous network using proteins called fibrin, and that is what's going to catch all the red blood cells to eventually form the plug. So, your plasma. It is mainly water. I'm pretty sure earlier this year I said 98% water. I'm sorry. Now that I'm looking at it, it's 91 to 92% water. And there is a ton of other stuff in there as well. We have proteins, nutrients, a ton of hormones. We already talked about the endocrine system. And then even plenty of electrolytes, including sodium, potassium, calcium, all of the things that you need to survive. So your plasma's job is to transport those nutrients. There are a few gases that are dissolved. There are some water-soluble vitamins and water-insoluble vitamins that will attach to certain proteins to then be transported. We are also regulating the fluid concentration of your body. If you are really, really dehydrated, one of the first things that's going to go is your plasma. The plasma level is going to drop down a little bit. Antidiuretic hormone is going to be secreted by the posterior pituitary to target the kidneys to conserve water so that way you don't lose as much fluid. And then your plasma is also there to help maintain a proper pH. Very similar to how we have this Goldilocks zone with temperature, pH needs to be optimized in order for your enzymes to work properly. So, floating around in that plasma, we have a lot of proteins. And these proteins are going to be some of the main dissolved substances found. What I need you guys to know is what the proteins are and in general what they do. The first protein is called albumin, and this is what helps establish an osmotic pressure. So we've looked at osmosis in the past, which is the movement of water from high to low concentration. If you put in pure water to your veins, then the water is going to flow directly into all of your cells. They're going to swell and likely burst. That's not good. So albumin helps make the solution isotonic to what your cells are. Your plasma has a lot of these proteins in order to make sure that the flow of water into and out of the cells is equal. And then albumin also has a special little superpower to help transport those lipids that can't be dissolved in water and other steroid hormones, which are also lipids, into the plasma so that way it can be equally transported and we don't get any like bubbles. Now, on top of that, globulins help transport tons of ions, lipids, and other fat-soluble vitamins, and even a few antibodies that tend to be water repellent. So the globulins help dissolve those things into the plasma. So I remember that globulins help with the dissolving of substances into the plasma by breaking down the globs. You don't want globs of fat. So the globulins help dissolve the globs of fat-soluble vitamins and other lipids into the plasma. And then the fibrinogen, this is going to be the main protein that your platelets are going to use to weave that meshwork that I mentioned earlier. So as soon as you start bleeding, there's a series of factors that are produced and a snowball reaction, not a snowball, a train reaction. Nope, that's not it either. There is a big reaction that happens that is going to help with those fibrinogens getting broken down into fibrin for then the meshwork to be produced. So albumin helps establish osmotic pressure, globulins dissolve the globs of fat, and fibrinogen helps with the fibers. Maybe a good way for you to remember albumin is with water is like albumin agua. Both of those start with A. So then, a few more things. In your plasma, I mentioned this earlier, we have a little bit of gas that's dissolved. A majority of your oxygen is transported by hemoglobin found in the erythrocytes. However, some of it does get dissolved directly into the plasma. And then carbon dioxide does get dissolved within the plasma, but then it's also broken down into bicarbonate ions. We're going to be looking at that more later on. So the plasma nutrients that I mentioned, we've got cholesterol, we've got amino acids, glucose, nucleotides, lipids, those simple building blocks that we talked about at the beginning of the year. Phospholipids, fats, triglycerides, lipoproteins. From this slide, what I need you to know is that we have the monomers, lots and lots of monomers of those macromolecules that are dissolved and floating around in the plasma. So, other substances, and these are not the good ones. This is what eventually will be excreted by the kidneys. Amino acids are eventually produced, and the urea and uric acid is produced. The urea and uric acid is specific to the cellular respiration. So a lot of these are waste products that eventually your kidneys are pulling out. And then we do have some electrolytes, like I mentioned earlier. We have the potassium, calcium, chloride, even a little bit of sodium that floats around. So this slide here, it is a great slide to put on your note card. If you are struggling to remember what we talked about in the blood unit after we've talked about the cardiovascular system for a really long time, this is a great place to go and to kind of refresh yourself and make sure that you have everything that you need on your note card. Next, we have homeostasis. So now we're going to start talking about some beneficial things and what happens when it goes wrong. Homeostasis is maintaining of the same. Right, so we're trying to maintain the same body temperature, the fluid concentration. Hemostasis is stopping the bleed. So hemo meaning blood and stasis meaning maintaining. So the stopping of the bleeding. I don't want to be losing blood anymore. So homeo meaning same, again, homeostasis, maintaining the same, and then hemostasis is stopping the bleed. So hemostasis, this is going to be critical when we start to damage the blood vessels, whether you bumped into a table really hard and broke a couple blood vessels underneath the skin and started bleeding there, which is eventually what forms a bruise, or whether you have a cut and are bleeding out. The first thing that's going to happen, and I do want you to write these down, the first thing is vasospasm. And this is when your blood vessels constrict. They get really small. And the idea is that the smaller the blood vessels, the less blood is going to be able to get through and the less blood we will lose. The second step is that the small itty-bitty platelets without a nucleus are going to start sticking together to then hopefully just plug that small little bit up. So first we have vasoconstriction, and then we have a small little platelet plug forming. The last step, and this is what's going to happen if the platelet plug is not sufficient, a blood clot is going to happen through coagulation. And that is when the platelets end up breaking down the fibrinogen into fibrin to form that meshwork to catch all the red blood cells. So let's talk about blood coagulation. And once again, this is when vasospasm and the platelet plug are not enough. So the formation of a blood clot involving the red blood cells or erythrocytes. It is going to stimulate the release of thromboplastin, which is a hormone, and then that's going to trigger a series of reactions, which I was trying to say earlier, including the prothrombin activator being produced. After the prothrombin activator is produced, it converts the prothrombin into thrombin, and then eventually the thrombin is going to cut that fibrinogen, the protein I said that was floating around in the plasma, into a meshwork over the damage to catch the red blood cells and plug everything up. So that's quite a bit. What do I need you to know? I need you to know that there is a reaction that does occur in order to eventually form coagulation. And that coagulation is using those plasma proteins to produce that meshwork over the damage to catch the red blood cells. So once again, coagulation, we're using the plasma proteins fibrinogen to produce a meshwork to catch the red blood cells and cover up that plug and make it so that no more blood can escape. So the clotting factor is produced at the site of the damage, which then is going to trigger that clotting, hopefully only at that place. We do see problems occur when that plug can break up and then travel down the blood vessel. That's pretty dangerous. That could cause a stroke, or that could cause a heart attack or a pulmonary embolism. There's a lot of other stuff that could happen. And so that's why a lot of people that are on blood clotting medication are told to get up and move around quite a bit. They're not allowed to sit for long periods of time, and it's because they don't want the blood pooling and for these blood clots to become dislodged and then move throughout the body. So once again, how does this whole thing happen? And this is all about hemostasis, the stopping of blood being lost to the body. First, the platelets are going to adhere together. That's going to trigger the fibrinogen to get broken down into fibrin. We're going to produce that meshwork, and eventually the thrombus or the platelet plug is going to be formed. This is specific just for the platelets. The coagulation is going to be when we have the red blood cells involved as well. So let's talk about some disorders. First, hemophilia. And there are a couple of forms of hemophilia. The main form, or the form that's most common, we find on the X chromosome, which means that women are less likely to have it because women have 2 X chromosomes. So if one of them is damaged, we have the backup. Hemophilia is when there's uncontrolled bleeding because one of those steps, a factor or a protein, is not being produced or changed correctly. Von Willebrand's disease is a form of this, or not a form, but similar to it. It's a tendency to bleed and bruise easily, and it's another type of clotting disorder. It's a lot less severe than hemophilia, but it is still kind of damaging. Hemophilia is what we saw a lot with the English royal family, and that's one of the reasons why a lot of their sons would pass. Now, the next slide does have some gruesome material. You're going to see a but, so please don't freak out. There is a but on the next slide. There's a but. Yeah, so this person has hemophilia, and they started bleeding up here, and then the blood pooled all the way down here. So you can see how much thicker their left ankle is than their right. And that's because the blood just started to flow down and eventually pooled and collected there. Other blood disorders, I believe we talked about leukemia. This is when you end up having cancer of the white blood cells. There are lots of different forms because there are lots of different types of white blood cells. And these are some of the signs and symptoms. One of the first diagnoses is going to be just way too many white blood cells. It is pretty dangerous. It's one of the leading causes of death for children. Or I guess I shouldn't say that. It is one of the most frequent cancers to hit children. Okay, and the treatment is a bone marrow transplant if you have that, or a lot of chemotherapy drugs. And that is it for today. Make sure you do your summary. If you have any questions, please let me know. And I hope you guys have a great day.